Dear ladies and gentlemen, welcome to my lecture on the topic Understanding BIM through a Simulation Game, case study of Indian students subjected to this course. I would like to share my screen with you to start my presentation. First of all, let me introduce myself. My name is Gregor Grunwald. I'm an architect living in Germany and appointed professor at the Jade University of Applied Science in Oldenburg in the north of Germany. My primary goal here at the Jade University is to create new educational offerings and educational structures to bring digital planning, especially building information modeling, closer to students. For this purpose, I've created a browser-based knowledge base with the support of the Stiftung Innovation in der Hochschullehre, a government funding initiative in Germany. Project title is Aufladen, which means charging. In the background, for research assistants and up to 20 student assistants are working on this project with the aim of creating self-learning courses on digital planning topics. The project is embedded in a three-part training structure. It consists of the BIM starter, the BIM Nuggets, and the BIM game. The BIM starter is a kind of appetizer, a short event to get to know the idea behind digital planning. The BIM Nuggets are self-study courses for digital design. They consist of video tutorials, click tutorials, practice exercises, and quizzes. Students create this learning material and prepare them in appropriate video and audio studios. The material is uploaded and made available on the project website. We make use of automation technology. We use robotic process automation to increase teaching efficiency. The applications are entered into UiPath with the goal of automated execution. When played slowly, it can be used to produce a relatively simple instruction manual for software. By acquiring knowledge through the BIM Nuggets, students qualify for the BIM game. The BIM game is an intensive workshop over several days that focus on the design of a building. Students are divided into different groups. Each group member is given a role in the team. In direct competition with other groups, students work on their project using the BIM methodology. An employer information requirement lists the deliverables, and at the end of the competition, the results are presented to a jury and a winner is chosen. The short video illustrates how a BIM game looks like. Just follow this video. First, we start with a kind of introduction lectures and give an overview about the topics. We are visiting the building site to get an impression where the building is to be erected, and the group work is starting. Groups are mixed, and each of the participants gets a specific role: architect, visualizer, cost estimator, structural engineer, BIM coordinator. And from time to time, students gather and present their intermediate results in so-called client talk, which is visible here. Finally, the structure can be made visible with the help of AR glasses and presented to the whole audience. Same happened in Bangalore in India. After some introductory lectures, different groups were formed and the participants were assigned their roles in the projects. The 4 roles to be taken on were those of the architect, the structural engineer, visualizer, and the BIM coordinator. The students were given the design task, and with the task sheet, an employer information requirement defined the digital delivery services in the game. Click tutorials shown in the top right picture explain how to deal with the software. With Autodesk Revit and the Construction Cloud, BIM 360, a software for 3D modeling, and BIM management were given to the students. This is the agenda of the workshop. We started by dividing the students into groups and assigned a role to each group member. The general work platform where all participants collaborated is the common data environment, which the client also had access to. The role of the client was overtaken by the teachers. The common data environment is the central storage where all the digital results were stored, according to the requirements of the EIR. In terms of time, we divided the workshop into 3 phases. The first phase was a clearly structured task phase to get to know all planning tools. In phase 2, the students were able to apply these tools to their own design, which they then presented to a jury and all the other participants in phase 3. Learning objective in this intensive workshop were 3D modeling, the creation of level references in Revit, the derivation of different models such as a structural model, for example, the proper filling of data according to the specification from the EIR, handling property sets in Revit, adding information to the model, the export of IFC models, the subject these IFC models to clash detection in order to discover errors in planning. These failures had to be commented and sent to group members responsible to solve the problem. For this communication, the students used the BCF format. All issues were tabled and documented in the CDE, which made it easy to check for the students' performance. They learned how to mark objects in their model for a proper coordination process within their groups, and had to use the approval process for ultimately handing out their final results to the client. Everything aligned with the requirements from the EIR. Teachers support in the design phase. At the end of the event, the design results were visualized on a 1-to-1 scale with the help of AR glasses. The students were thus able to experience and enter their designs in real proximity to the neighbor buildings. A jury selected the best design and the participants were presented with certificates. In the shortest time, interesting building designs were created, all of which were enriched with information in accordance with the EIR specifications and documented on the CDE. Here in Bangalore, it was about a student cafe that was to be planned. Some of the results of this workshop are documented in my article, such as the difficulty students had in creating property sets to store additional information on the 3D model in orderly fashion. The IFC export from Revit also caused difficulties for many participants. This table gives an overview about the evaluation of different tasks. However, the article also reports on the automatic creation of the EIR using a software called BIMQ. With the help of BIMQ, comprehensive and well-structured information requirements for a project can be centrally defined, distributed, and processed. This simplifies the setup of the EIR and also provides checking rules for the Solibri software, which checks the students' models for consistency and quality. By using BIMQ, a lot of time could be saved in evaluating the results, and the winner could be determined relatively quickly. Please refer to my paper, Understanding BIM Through a Simulation Game, case study of Indian students subjected to this course. You will find further information and useful links here. Thank you very much for listening and have a nice day. Bye-bye.